for concavity. A graph that's concave upward looks like this. It is either decreasing at a decreasing rate. So that means it's going down, but it goes down fast at first, and then at a slower and slower and slower rate. So that would be what it would look like if you're decreasing at a decreasing rate. That is concave up. Or you're increasing at an increasing rate. So you go up, and you start off really, really slow, but the rate at which you're increasing gets faster and faster and faster. So that would be increasing at an increasing rate. Both of those situations would be concave up. Concave downward, it's going to look like this. For concave downward, you're either increasing at a decreasing rate, so you're going up quickly at first, but then the rate at which you increase decreases. So fast at first, then slows down. Or you are decreasing at an increasing rate. So you start off decreasing slowly, and then that gets steeper. So when we think of these things, when we think of concavity, we're thinking about the increasing or decreasing, which we can find from the first derivative. And then we must think about the rate at which the function is increasing or decreasing. And the rate that you're increasing or decreasing is going to be the second derivative. Okay? So if you have something that's concave upward, if a graph is concave upward, the slope of the tangent line increases from left to right. So like if you think of something concave upward, if you drew in some tangent lines here, you would have a negative, really steep slope. Right here you'd have a little less steep, but still negative. At the minimum, it'd be 0. Here, it would increase. So if you think about the slope, like right here, maybe that slope's -2 and -1 and 0 and 1 and 2. Right. So if you have something that's concave upward, then the slope of the tangent line increases from left to right. So that means that the slope of the tangent line, that is your derivative. So your derivative is increasing. Now, if we want to know if something's increasing or decreasing, we look at its derivative, right? So we can have a function that's concave up and still decreasing. But the derivative has to be, the derivative of the derivative has to be positive, has to be increasing. So if f prime of x is increasing, f of x is concave upward. What is that? So if your derivative is increasing, then the original function is concave upward. Same thing, but the opposite, if you have something that's concave downward. If you think of the tangent lines, so like right here, if we just kind of estimate, maybe that's the slope of 2, that's the slope of 1, 0, -1, -2. So if you have a graph that's concave downward, the slope of the tangent line decreases from left to right. So the derivative, which is the slope of your tangent line, has to be decreasing. And so if we want to know if something's increasing or decreasing, we look at its derivative, and so whether it's positive or negative. So if we want to know if the derivative is increasing or decreasing, we're going to look at the derivative of the derivative, which is the second derivative, right? So the main thing that you have to remember, if f double prime of x is positive, that tells you that the derivative, first derivative is increasing, which means f of x has to be concave up. And if the second derivative is negative, that tells you that the first derivative is decreasing, which means that f of x has to be concave downward. So, this is the main thing you just need to know is if second derivative, you really don't even have to say this middle part. If second derivative is positive, f is concave up. If second derivative is negative, f is concave down. Those are your main things you've got to know. So when you get a question like example 1 that's asking you for concavity, you're going to look at the second derivative. So this one's very simple to take the derivative of. You would have 3x squared minus 18x plus 24. And then you would, that'd be our first derivative. Then we would need to take our second derivative. And so we get 6x minus 18. And basically we want to do just like we were doing our sine lines with our increasing and decreasing functions, except for using the second derivative. So we're going to set this equal to 0. So 6x would equal 18, so x would equal 3. And so this is a really simple one. So your second derivative, if you plug in a number less than 3, like 0, you're going to get negative. And if you plug in a number bigger than 3, you'll get a positive. Sorry, yes. So, for this, if it asks, this particular question said tell where the function is concave up and concave down. So we would say that f of x is concave up for x is greater than 3. And we would have to say because f double prime of x is positive or greater than 0. You don't have to say anything about the derivative. The derivative would be increasing, which means that the function would be concave up, but you don't have to say anything about that as far as the explanation goes. So second derivative is positive, f is concave up, and then we would say f of x is concave down. For x is less than 3, because f double prime of x is less than 0. Okay, questions? You'll see down there at the bottom, it has this phrase, points of inflection. A point of inflection is points on the graph where concavity of the graph changes. And so, at this particular case, the point of inflection would be at x equals 3, because your concavity changes at that point. Okay, questions? All right, we've got another example. We've got f of x equals 6 times x squared plus 3 to the negative 1. So we've got to take the derivative twice for this. So our first derivative for this one, Wendy, what will we get when we take that derivative? Almost. It's going to be x squared plus 3 to what power? Negative 2. Make sure you remember to do that. And so let's clean that up a little bit before we take the second derivative. This would be negative 12x over x squared plus 3 squared. I'm not sure, but he was doing that during second period from Planet 2. Maybe it has a point. Okay, questions there? Alright, we must take the second derivative. So we've got to take the derivative again. So, Lakin, what would we do to take that second derivative? Good. Mm-hmm. This is just x squared plus 3 to the second, not the square root of it. So it's just going to be a 2 there. So. Okay, and then so this right here is a little tricky because you got to use that chain rule, so be careful with that. Oh wait, that'd be x squared plus 3 squared squared. Okay, so we've got f double prime of x. X squared plus, let's see, how do I want to do this? What's going to be easiest? Probably easiest thing to do here. Notice how you've got an x plus 3 squared with both of these. It is probably easiest to go ahead and factor one of those out. So x squared plus 3, we'll pull that out front. And that would leave us here with negative 12 times x squared plus 3. And then in the second expression, the x squared plus 3 will be gone, so we'll have the negative 12x times 2 times 2x. So that would give you, there will be a plus 48x squared all over x squared plus 3 to the 4th power. You can, but you will have to use a product rule if you do that. Because what you'll have there will be negative 12x times x squared plus 3 to the negative 2. So if you take the derivative that way, you've got to use the product rule because you've got this times this. So you can do it, but you'll have to use the product rule. Alright, so one of these can cancel here, which is the reason I did it that way in the first place. We could distribute our negative 12, so we'd have negative 12x squared minus 36 plus 48x squared all over x squared plus 3 to the 3rd. And so that gives us 36x squared minus 36 over x squared plus 3 to the 3rd. questions? So, we are going to make ourselves a chart for this. For this, you want to do, these are technically not called critical values, because it's the second derivative, but it's like the critical values. You're going to set both of those equal to 0. So you'll have 36x squared equals 36, which means x squared equals 1, which means x equals plus or minus 1. And then over here, you're going to have x squared plus 3 equals 0. So x squared equals negative 3. When you take the square root of both sides there, you get a negative over the square root, so you don't get any critical values from that. So we just have negative 1 and positive 1. And if you think of what you're doing here, you've got the 36x squared minus 36. You've got the x squared plus 3 to the third. And so, if you look at this, x squared plus 3 is always positive, because when you square something, it's positive, and then you add 3 more to it, so it has to be positive. So this row is all positives. If you pick a number to plug in less than negative 1, like negative 2, you could have 36 times negative 2 squared minus 36. That's 36 times 4 minus 36. Not really important what that is, but it is going to be a positive number. If you pick a number between negative 1 and 1, like 0, you're going to get a negative. So we'll have a negative here. And then if this was a positive 2 here, we'd still get the same. So we get positive, negative, positive. And so whenever we have a positive second derivative, that tells us that we're concave up. For f of x, this is down, this is up. So we would say, and you have to write this whole thing out. If it's free response, you have to say f of x is concave up for negative infinity to negative 1 and 1 to infinity, because f double prime of x is positive and then you would say f of x is concave down for negative 1 to 1 because f double prime of x is negative. Okay. Questions? Okay. So, for I'm going to skip example 3. It's going to take a while, and it's a lot like the one that we just did. Almost get it. Let's look at 4. Alright, so we want to know if f of x is defined from 0 to 2 pi, where is f of x equals cosine x minus sine x, concave up. So, second derivative, so first we got to take the first derivative, which is going to be negative sine x minus cosine x. And then we have to take our second derivative, which is going to be negative cosine x plus sine x. And we want to know where this equals 0. So that really is just asking us where sine x equals cosine x. We move that cosine x over to the other side. And so on our unit circle, where does sine x equal cosine x? So it has to be first quadrant and third quadrant because that's where our signs are the same. Pi over 4 is one of them. That's the one in the first quadrant. And 5 pi over 4. So those are our points we're going to put on our line. And so if we are thinking about numbers to pick in between here, from 0 to pi over 4, the only thing we know there is pi over 6, which is root 3 over 2, 1/2. So f double prime of pi over 6 would be negative cosine. Cosine's the x coordinate, so negative square root of 3 over 2 plus sine, which would be 1/2. Doesn't matter what number that is it positive or negative? It is going to be negative because square root of 3 is larger than 1, right? Because square root of 3 would be close to 2, right? So we get a negative here. Now between pi over 4 and 5 pi over 4, I would either pick pi over 2 or pi. Let's say if we pick pi over 2 here, coordinates there are 0, 1. So we would have f double prime of pi over 2 would be negative 0 plus 1, which is 1, so that's positive. And then for 3 pi over 2, right here is what I would pick between 5 pi over 4 and 2 pi, just because it's one of the easier points on the unit circle. And the coordinates we have there are 0, negative 1. So you would have f double prime of 3 pi over 2 would be negative 0 plus negative 1, which is a negative value. So a negative there. And so we can see that this function is concave up between pi over 4 and 5 pi over 4. So we would say f of x is concave up for pi over 4 less than x less than 5 pi over over 4 because f double prime of x is greater than 0. Okay, questions? Couple more. For 5, we've got to give points of inflection. For points of inflection, you need to see where concavity changes. So again, second derivative. This one's not the easiest derivative in the world to take. This is natural log. I'm going to think of this as natural log of x squared plus 4 to the 1/2. So we have a chain rule here, but it's going to be a double chain rule for this one. So f prime of x, when we take the derivative of natural log, it's 1 over whatever is inside of the box. So it's going to be 1 over x squared plus 4 to the 1/2. Then we have to multiply by the derivative of x squared plus 4 to the 1/2. So we've taken the derivative of this outside box. Now we take the derivative of this inside box. So to take that derivative, we still have to use chain rule because we've got this very inside part here. So we'll have to do x squared plus, 1/2 x squared plus 4 to the negative 1/2 times the derivative of x squared plus 4, which is 2x. And so when we simplify this, we're going to have the 1/2 and the 2, they cancel each other out. The x is going to stay on top. And we'll have x squared plus 4 to the 1/2. And then we'll move another x squared plus 4 to the 1/2 to the bottom. And so we could combine those and just make that x squared plus 4 to the first power. That's only the first derivative, so now we got to take the second derivative. So f double prime of x, we've got to use quotient rule here. So we're going to have x squared plus 4 times the derivative of the top, which is 1 minus x times 2x all over x squared plus 4 squared. If we simplify that, we've got x squared plus 4 minus 2x squared over x squared plus 4 squared, which is greater than 4 minus x squared over x squared plus 4 squared. Alright, so we've got to find our critical values for this. We're going to set top and bottom equal to 0. So 4 equals x squared. We square root both sides. Plus or minus 2 are the values we get there. Right here, I could set this equal to 0. I'm going to have x squared plus 4 equals 0. I'm going to move that over. I'll have x squared equals negative 4. You don't get any critical values for this. X squared plus 4 is always positive. So you will not have any critical values there. So if we make ourselves the chart, we really only have to look at the top part of the function because this bottom part's always positive, so it doesn't change anything. So if I plug in a number below negative 2, like negative 3, 4 minus negative 3 squared is going to be 4 minus 9, and that's going to give me a negative number. A number between negative 2 and 2, like 0, 4 minus 0 squared is going to be a positive number. And then for our last problem, our last section, if we plugged in a number like 3, you'd get 4 minus 9 again, get a negative. And so this question asks us to find the points of inflection. It does not say that we only have to give the x-coordinates, so we would assume that we need to find the y-coordinates as well. So we have points of inflection at negative 2 and positive 2 because our second derivative changes sign, which tells us that we change concavity. But we also need to find f of negative 2 and f of positive 2. So f of negative 2 is going to be natural log of the square root of negative 2 squared plus 4, which is natural log of the square root of 4 plus 4, which is natural log square root of 8. I'm going to do something here just because I'm afraid that they'll do it. They could do some crazy stuff here. But this is natural log of 8 to the 1/2 power. You guys remember what you can do with this power for natural log? It can be pulled out front. So it'd be 1/2 natural log of 8, or they might write it natural log of 8 over 2. Now, for response, just leave it natural log square root of 8. You don't have to do anything to it, but I'm just afraid on multiple choice they may do something like that. On multiple choice, they might be really cruel and say natural log of 8 is natural log of 2 to the 3rd, and then pull that out front and give you 3/2 natural log of 2. That's if they're really, really mean. But maybe they won't do that. But this is the y-coordinate. So that means we have a point of inflection at negative 2 natural log. I'm just going to write natural log square root of 8. If we change this to a positive 2 right here, it does not change anything about what the answer ends up being because 2 squared is still 4. So we would also have a point of inflection at positive 2 natural log of square root of 8. And so we would say f of x has points of inflection at these 2 points because f double prime of x changes signs for its values. You don't have to tell from negative to positive or positive to negative, although you can. questions? Last one. Alright, so we want to know where is f of x equals e to the negative 2 over x concave down. So we have got to take the second derivative, and we're going to have to use a chain rule here. And before we do, I'm going to write it like this: f of x equals e to the negative 2x to the negative 1. So rather than having negative 2 over x, we can move that x back up here. So if we take the derivative of e to something, it is just e to that power. So we've got e to the negative 2x to the negative 1. But then we must multiply by the derivative of that inside part, which is what you've got right up here. So we have to multiply by that derivative, so we would have positive 2x to the negative 2 power. And so that is going to give us 2e to the negative 2x to the negative 1 over x squared. And we can, to take the second derivative, we could leave it like this and use a product rule. Or we could use it like this and use a quotient. Really doesn't matter which one. Since we did quotient on the other one, let's do product on this one just to see. F double prime of x would equal e to the negative 2x to the negative 1 times the derivative of 2x to negative 2, which is negative 4x to negative 3, plus 2x to the negative 2 times the derivative of e to negative 2x minus 1, so e to negative 2x to negative 1 times the derivative of negative 2x to negative 1, which is going to be 2x to negative 2. Alright, questions so far? Notice we have e to the negative 2x to the negative 1 with both of these. So let's factor that out front. E to the negative 2x to the negative 1. And that leaves us with negative 4x to negative 3. Plus, here we get 4x to the negative 4. It will not be here because we will add the exponents to that. So we've got to figure out where this is positive and where this is negative, which is not all that easy with all these negative exponents. So I would probably do this, this e to the negative 2x to negative 1. It really doesn't matter. You leave it alone. But over here, I would make this negative 4 over x to the third plus 4 over x to the fourth. And then I would get common denominators. So if I just multiply this first term just by an x, that gives me x to the fourth in both denominators. So I would have e to the negative 2x to the negative 1 times negative 4x plus 4 over x to the 4. And so we want to set all the parts equal to 0. The numerator part, e to the negative 2x to the negative 1, e to any power is always positive. It does not equal 0. So we don't really have to worry about that. So we're setting this equal to 0 and this equal to 0. So we get negative 4x plus 4 equals 0. So 4 equals 4x. So 1 equals x. And down here with that fourth root, we're just going to get x equals 0. And so we will make our that was a chart. And we'll use all the pieces. We've got e to the negative 2x to the negative 1. We've got negative 4x plus 4. And we've got x to the 4th. Our values here, 0 and 1. So as I said earlier, e to the negative 2x to the negative 1, that is always positive. E to anything is always positive. And x to the 4th is also always positive except for when it equals 0. So really we're just looking at this middle part. And so we have, if we plug in a negative number like negative 1, we'll get positive 4 plus 4. We'll get a positive number here. A number between 0 and 1, like 1/2, we'd get negative 2 plus 4. That'd also be positive. And then any number bigger than 1, so like 2, we would get a negative value there. So our second derivative, we get positive, positive, negative. This might be one of the first few that we've seen where signs don't alternate. It's not positive, negative, positive, negative. They do not always alternate, so be careful with that. So, what did the question even ask us? Where is f of x equals e to the negative 2 over x concave down? For this, we would say f of x is concave down for x is greater than 1 because f prime, double prime of x is less than 0. All right, any questions?